This is where we were in the last video. We are ready to do question 3. Convert 4 plus 7i to polar form. Alright, let's just erase what we did for the work in question 2 and see what we can do with question 3. Alright? Now, question 3. And remember, I told you before that you must do all the questions. So if you're trying to trick me or cheat and did not do all the question and you didn't do question 3, it's now a good time to pause the video, confess what you did, and then work out question 3. Alright? Oh, good. Now, here, 4 plus 7i, we're going to convert it to polar form. It's always a good idea to do a little sketch to see what the complex number looks like. So if we have our x on our y-axis, let me try and put this thing straight. So we have, let me draw it down a little bit more, because we might use some space above these lines. So we have our x and our y-axis. You have 4 plus 7i. That means from the origin, you go 4 to the right is positive, and plus 7i positive, you go up. So here we have our complex number, where the end is located above 4 and beside 7. So this is 4 plus 7i. Now, you remember that you're going to have an angle here. Call it theta. This angle can be in degrees or radians. But if the question that you get specify which, you just have to stick to that. I'm going to work it out in degrees. Now, here, this is a right angle triangle. So let me say this is one side, and if you don't remember the format of the polar form, we can say that the cosine of theta is the adjacent, which is here. So that is 4. It's 4 long divided by the length of the hypotenuse. Now, the hypotenuse is this. So we cannot move forward until we get the hypotenuse. What is that hypotenuse? Let's call it r. Usually they use r, as I said before in previous video, because if you draw a circle, the length where the complex number ends up would be a radius. Now, by Pythagoras theorem, r squared is equal to 4 squared plus 7 squared is equal to 16 plus 49. So r squared equals, what is 16 plus 49 again? And by the way, let me write this a little bigger, right? If you're using a phone, you want to see the thing more clearly. So r squared equals 4 squared plus 7 squared by Pythagoras theorem. And this is 16 plus 49. So r squared is what? 9 and 6, 15. Bring down 5, carry 1, 4, 1, 5, 1, 6, 65. So r is the square root of 65. Alright? Now, you can use a calculator and get the exact and get an approximate value. But I'll just work with the square root of 65 for now. So it is 4 over the square root of 65. So therefore, and remember, I'm assuming that we don't have a formula sheet to look at the format when you convert it from rectangular to polar form. And I'm assuming that you don't remember. So we're deriving it for the purpose of this question. So what we have is that 4 equal square root of 65 cos theta. Then what we have here is 7, and that would be the opposite side to the angle. The angle is on the left, the 7 high is on the right. That side which is 7 high is on the right. Now, sine theta is the opposite, which is 7 over the hypotenuse, the length of the hypotenuse, which is square root of 65. So therefore 7 equals square root of 65 cos theta. See that? Oh my, why jump all the way up here? So therefore, what we have now is that this complex number is going to be in the form r squared is equal to 4 squared plus 7 squared. Now, we know what that will give, but we want to write it down. The 4 squared. This 4 squared is going to be square root. I have it here. Square root of 65 cos theta squared. All of this will be squared. Alright? But we would write that. We can't just put it in our bracket like this. Then we plus, and then we continue applying the Pythagoras theorem here to say that this part would be 7. So it is square root of 65 cos theta r squared. So that was deriving the format of the complex number. But now, that is the radius. Now let's write the 4 plus 7i in this form. So the complex number z is, remember this is 4 squared, you know, and 4 in this case would be square root of 65 cos theta. So what we have is square root of 65 cos theta. We're not squaring them like we're doing up here using the radius and Pythagoras theorem. We just write out the plain complex number as it appears. So that plus I times the square root of 65 cos theta. That is the entire complex number. Now you remember the general format is going to be, if you have this and the angle here, and this is A and this is B and this is R, right? You have R squared equal A squared plus B squared. So R squared is A. If you find cos theta, it's going to be A over R. So A is R cos theta. So it is R cos theta, R squared, that is A squared plus B squared. Now, what is B? B if you want it, you say sine theta, this angle, equal the opposite, which is b, over the hypotenuse, which is r. So b is equal to r sine theta. So is r sine theta, r squared here, that's b squared. That is the magnitude of the complex number squared. But what is the complex number? The complex number is, now remember, z, I had put the slash here, z is a plus ib, alright? Or in this case, bi. It sounds a little bit better if I say bi instead of ib. So it is a, remember a squared is r cos theta squared. So a is r cos theta plus I b I r sine theta. I put the I to the left this time because it sounds a bit more comfortable to say IR sine theta instead of R sine theta I. It sounds as if you're multiplying theta by I and then finding the sine. Alright? So that's the general format. Now here, this what we have up here is the format of this particular complex number. Right? Now, we could find out what, no, we have to find out, yeah, because we have the theta here. We need to find it just like how we find r squared. Right? Now, what is theta? You know that from your memory of trigonometry. Tan theta equal opposite, which is 7 over adjacent, which is 4. This is 7 over 4. So theta is tan inverse of 7 over 4. What is the tan inverse of 7 over 4? Let's read for our calculator and work that one out. Alright? Alright, we have our calculator now. So we want the tan, where is it? Inverse of, to make sure we open the bracket, put 7 over 4, close bracket. Alright, tan inverse of that, and we have our calculator in degrees, good, equal 60.25, call it 60.26 degrees. So we have 60.26 degrees, you see that? So therefore now, we can continue from here. I diverted a bit, showing the general format. But let's continue. We have theta as 60.26 degrees. So therefore, z equal the square root of 65 cos 60.26 plus I square root of 65 sine 60.26. So that's the format we have, the form of the complex number. Now before we finish, we want to test it. You see, when you calculate all of that, it should give you back 4 plus 7i. So we want to see how this goes. Let us look back at our calculator. Here's the calculator. Alright. So, what we have here is the square root of 65 multiplied by, what is it again? Cos 60.26. So, we have the cosine of 60.26 equal 3.99999, call it 4. So Z equal 4 plus what? We need to get back our calculator and find square root of 65 sine 60.26 and see what we get. So we have the square root of 65 multiplied by the sine of 60.26 equal 7.0000, call it 7. So 7i, I could call it I7, alright, or 7i. 7i sound a bit more comfortable to say. So it's 4 plus 7i. Was it what we had? 4 plus 7i. Alright. So it's the same complex number, but in polar form, it is z equals square root of 65 cos 60.26 plus I square root of 65 sine 60.26.